Hello, this is Susan Poss again at Spartanburg Community College. I'm still working in section 8.1. This is my second video. So in the previous video, you were given the solution and asked to check the ordered pair in both equations to see if they balanced. This time, you're not given the solution. You're given two equations, and you're asked to find the solution. And the technique this time that we're going to be using is to find it by graphing. Later in the chapter, we'll be doing algebraic techniques, and again, in your college algebra class, you'll be learning about something called matrices, which are used for solving systems. All right, so here are the two equations that we've been given. We are looking for the solution, the point, the ordered pair that satisfies both of these equations at the same time, balances both of these at the same time. So you can see I've separated out here in blue, you see equation number 1. Lower down in green, you see equation number 2. And I went ahead and did a lot of the work. I'm taking the first equation and I'm solving it explicitly for y. This is using what's called slope-intercept form. You would have studied this back in your first Math 101 class. If you need to go back and review Chapter 4, I've got videos posted in 101 to help you review Chapter 4. All right, so I took it, solved it explicitly for y, and now I can tell you that the slope of the line is 3, and I can tell you that the y-intercept is at -10, and you see that information here and here. So let's go over here and plot the graph of this first line. So remember, we're going to start at the point, the y-intercept, which is 0, -10, which is way down here. And then I'm going to count off this slope, which is to rise 3, run 1. Rise 3, run 1. That's hard to say. Okay, now I'm going to do my best to try on this slippery surface to get a halfway decent line, because your graphing is really important. It's got to be very accurate for you to get the correct answer. This is equation number 1 that I just graphed there. All right, so in equation number 2, I decided to use a different technique. I decided to go with x and y intercepts. So in order to find the y-intercept, I plugged in a 0 for x, and you can see that I got a corresponding -6. And to find the x-intercept, I plugged in a 0 for y, and you can see that I got a corresponding +6. So let me plot those 2 points. 0, -6. Let me do this in a different color. I wish I'd color coordinated a little bit better than I did. 0, -6 is here, and 6, 0 is here. And again, let me see if I can do a good job of drawing a nice line. Well, it's not real good, but I hope we can see what we're looking for. So what we're looking for here is the one point on this graph that is shared by both of these lines. So that point that I highlighted there in red is a point on the first equation, or a solution in the first equation, and it's also a solution in the second equation. So let's see if we can determine the coordinates of that point. How do we get there? We have to go 2 to the right, and we have to go 4 down. So this point has coordinates 2, -4. That is the solution, because that is a point on the first equation, and it's also a point on the second equation. Now, if this were a test, again, graphing is sometimes inaccurate. I would do what we did in the earlier video and run back to equation number 1 and see if, yes, it checks in the first equation. Now let me go to the second equation. The second equation is x minus y equals 6. And I think you can see that once I do the sign changes, that one is also going to check. So I know that that point with coordinates 2, -4 is a solution to both of these equations. All right, so I think I'm going to do one more real quickly with you here. Here's another system. We are asked to find the solution, the point where they intersect. And you can see I've separated out there equation number 1 in blue. And I've explicitly solved it for y to get it in mx plus b form. You can see that the slope here is 1 and the y-intercept is -3. So once again, I'm going to start with the y-intercept and plot that point, and then from there count up 1, right 1. Up 1, right 1 to get this slope of +1. By the way, lines that have slopes that are +1 intersect the horizontal at a 45-degree angle. That is something that later you will want to know in some of your higher level math courses. So there's my first one in blue. Let me get better with my color coordinating this time. All right, here's the second one in red. I took it also and solved it explicitly for y. And you can see the slope of the line here is this -1/2. And you can see that the y-intercept is at 0, 9. So in red, let me find 0, 9. Remember, that's my starting point. And then from there, I go drop down 1 and to the right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. And of course, you don't have to do those. You can be working with a straight edge. I, of course, cannot work with a straight edge here. But these lines work out nicely for me. So again, we're looking for the solution to both. And the solution to both is that one point where they cross. That is a solution on the first equation and also on the second equation. Let me determine those coordinates. It looks like we go out. So 8 to the right, and what is that, 5 up? So my solution is 8, 5, and again, I would go back quickly into the equations and do that little double check. And of course, this is 8 plus 10. All right, so I've got a check in both of those equations. All right, so I think that's a good spot to stop for a minute.